Hello, folks. My name's Ramin and I recently moved to the US to start a position as a postdoctoral researcher working for the University of Maryland, Baltimore County, where I'm actually based at NASA's Goddard Space Flight Center in Greenbelt in Maryland. So I'm actually just starting to do some research on a very mysterious phenomenon called lunar horizon glow, and I'm part of a team here that's trying to find out what causes it. So lunar horizon glow is basically this thin crescent of light at the horizon of the moon just before sunrise or just after sunset. It was seen in the 1960s for the first time by the robotic surveyor landers as they were finding out what was going on the moon and whether it was safe to land there for the Apollo astronauts. You can see basically the black sky at the top, the lunar horizon glow as that thin white crescent sort of in the middle, silhouetting the dark horizon at the bottom. And now, later on, these measurements were actually backed up by observations from the Apollo astronauts themselves as they floated above the moon at about 60 to 100 miles at sunrise on the moon. And in addition to that crescent of light that they saw on the moon, they also saw faint rays radiating out from the center, a bit like the rays that you get when you have holes in the cloud shining through, called crepuscular rays. Everybody's trying to work out, what is this weird phenomenon and what's causing it. Scientists basically think that it's dust floating above the moon at the horizon. The dust is basically probably floating around the moon all of the time. You can't see it during the day because basically the light of the sun is so bright that it sort of drowns out anything else. So you can't see it during the day. You can't see it during the night because it's dark. So you basically have to wait for sunrise or sunset to be able to see it because the sun has to be in just the right position. So basically what happens is the sun is below the horizon from the camera's point of view, and the camera's pointing at the dust grain. The light from the sun basically comes up and it hits the dust grain, and then it's scattered. And what that means is basically that a light ray can hit a particle, such as a dust grain, and then some of the light gets distributed in lots of different directions. Some of that light gets scattered back down and into the camera, and so this camera can actually see it. And when you have lots of dust grains all together, that basically gives you a glow on the horizon and basically gives you the observations that you saw in the photographs or what the Apollo astronauts saw. So you might think that scattering is something that only happens on the moon from what I've said, but actually scattering is something that happens all around you. An example of that is actually when you look straight up, and that's the sky. The color of the sky is blue because of scattering. And when you look at the sunset at night and it looks red, that's also because of scattering. So to explain a little bit more, we're going to have a go with an experiment making our own sunset in a glass with some water, milk, and a light. Okay, let's go. We start off by shining the torch through the glass of water with nothing in it. And basically you can see there's not really any difference between when you put the torch, when you shine the torch through the glass of water onto the wall versus when you just shine it straight on the wall. Let's see what happens when we add a little bit of milk. Now, we don't need to add very much milk at all, just a very tiny bit. So I actually only added 1/8 of a teaspoon to my glass of water here. And that's for 450 mils of water. You don't need very much at all. So start small and add more. But when I actually start shining the light through the glass itself, you can now see that the glass is blue. And you can see a bright patch from the beam of light as it shines through the water, and you can see that the spot on the wall is yellow. Well, this is basically scattering in action. The thing here is that different colors of light are being scattered differently. So blue light is basically scattered more easily than red light. So what happens is the blue light gets scattered out the side of the glass by the particles of milk floating around in the water, and that's basically why you see the blue glow. So this experiment basically mimics what happens with the sun and the sky. So our torch is our white light source, and that is functioning like the sun. So the sun is actually white itself up in space, because when you're up above the atmosphere and above the air where there is no scattering, the sun just looks white. It only looks yellow or red down here on the surface of Earth because of scattering. So the glass acts like the atmosphere, scattering the blue light out of the beam. So basically the light from the sun comes in, goes through the sky, and the blue light is scattered out, and that's why the sky looks blue. And then the red spot on the wall is basically like the sunset. So at this point, all of the blue light is being scattered away and only the red light is left, and that makes the sunset look red. During the day, because the sun is higher up in the sky, the light has to travel through less atmosphere. So even though you still get the blue scattering, that makes the sky look blue. The sun looks more yellow because there's less scattering going on for the light that reaches your eye. So it looks yellow rather than red. So yeah, that's the million-dollar question that everybody's trying to answer. So there's actually been a few different theories. So the initial theory was actually electrostatic repulsion caused by the solar wind. So basically, the solar wind comes and it hits the moon, and it causes the dust on there to be charged, and then those dust grains basically repel each other in the same way that this north and like if you put two poles of magnets together, like the same poles, they'll push away from each other, and so that raises up some of the dust from the ground, and that can explain basically just that sort of low down, which might have been the majority of the glow that the surveyor lander saw, but it doesn't explain what the Apollo astronauts saw, because their observations were a bit different from what I showed you in the surveyor pictures, and they were obviously much, much higher up. And so electrostatic repulsion caused by solar wind can work for getting the dust up a little bit off the ground, but it's probably not strong enough to get it all the way up to where they were, which is about 60 miles, orbiting about 60 miles up. So the team that I'm working with basically think that it's actually being caused by meteoroid impacts. So basically, things come along, they hit the moon, that raises up a cloud of dust, and that dust gets basically raised up into what's called the lunar exosphere. So normally when you talk about the moon, you would say the moon has no air, so you would say it doesn't really have an atmosphere. However, that's not strictly true. The moon actually has a very, 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 very thin atmosphere, and that's referred to as an exosphere. So it's basically a vacuum for all intents and purposes, and you certainly couldn't breathe in it. But there are things floating around the moon, and one of the things we know floats around the moon, which was shown by the Lolachi mission, is that there's basically a cloud of dust floating around the moon. And so we know that it's there, but we still aren't sure on how it got there in the first place. And that's sort of why this theory of meteoroid impacts coming along, hitting the surface and raising up clouds of dust might be one mechanism to get dust up to those high heights of, about 60, 100 miles up. Well, if I was on the surface of Mars, actually, things look a bit different, basically the opposite way around. So on Mars, the sunset is blue and the sky is more of an orange color. And that's basically because the Martian atmosphere is different to our own and has lots of tiny particles of dust suspended in it. So why did I get into planetary science in the first place? Well, it actually has to do with my granddad. So basically, as I was growing up, my granddad worked for the coal board in Dunstan in Newcastle as chief chemist there, but he was also really passionate about astronomy as well. And he actually used to build his own telescopes, and he got me into astronomy as well through that and made me passionate. As I started to read up about it and learn more about it for myself, I realized that what I really liked was planetary science and the ability to explore other worlds. And it was reading about robotic spacecraft like the Voyager missions and the Viking missions that really sort of inspired me in that way. So what kind of skills do you need to be a planetary scientist? Well, number one really is curiosity and a sense of wonder, wanting to learn more about what there is out there and how it works. In terms of more practical skills, coding is really useful, and the ability to code and problem solving. Those are probably the two most important things that you need to be able to do. And maths, some maths wouldn't go astray either, and that helps quite a lot as well. But yeah, I mean, the main thing really is just a desire to learn more about these worlds and to be curious. So yeah, if you want to do that, have a go. It's a lot of fun. Now that you've seen how to do the experiment, why don't you have a go yourself and upload your pics and videos to the comment section below. Right, well, that's all from me, folks. Thanks very much, and I hope you have fun having a go. Bye.